which is a part of the public lecture series, which has been organized, which the Department of Science Education at IISER Pune has been organizing for the past 6 to 8 months. Our speaker today is Professor Jill Adler, and I welcome her on behalf of the department's coordinating committee. Professor Adler is a professor of mathematics education at the University of, and I promise I will say this properly, Witwatersrand, or Wits in South Africa. I'm sorry if I massacred that pronunciation. She was the president of the International Commission on Mathematical Instruction from 2017 to 2020, and held the Wits South African Research Chair's Initiatives Mathematics Education Chair from 2010 to 2019. Professor Adler's research focuses on teaching and learning in multilingual classrooms and teacher professional development. She's a recipient of numerous awards for her work in mathematics education, including the 2012 Academy of Science of South Africa Gold Medal for Science in the Service of Society, and the 2015 ICMI Hans Freudenthal Medal in recognition of a major cumulative program of research. We welcome Professor Adler, and we look forward to hearing her. Professor Adler, the floor is yours.
Thank you very much, and thank you very much for this invitation. It's a pleasure to be here with you. And I'm not going to waste time and just go straight into it so that there's time to talk, and we also have time for discussion. So the title tells you what I'm going to be talking about, which is levering educational change. What does it mean to do a project that looks for improving educational outcomes? And we were doing that through a maths teacher professional development program. So it was a 10-year program, and we did interventions in the schools, and we did research at the same time. So I'm going to talk about those linked activities. So briefly, I'm going to start with trying to give you an insight into what the problem was that we thought we were trying to address. And WMCS stands for the Wits Maths Connect Secondary Project. So my focus is on mathematics and at the secondary level. I'll then describe the intervention, what we wanted to do and how we thought it would lever change, the model that developed, and some of the practices and processes that unfolded as we did the work. And then I'll present the research that we did, both qualitative and quantitative, and some of our findings. And I do want to remind you, there's the dates, that this was pre-COVID. And I'll come back at the end to say, you know, what has happened in the last couple of years during and now that schools are back. And the other thing, of course, I know it's a STEM center, but or a STEM institute that you have, and I will focus only on mathematics. I do think some of the things that I'll talk about are relevant for science, certainly for science education. What I mean by that is physics and chemistry education. I'm not so much sure about biology education, but I think so, and we can have some chats about that. And so I will come at the end to look at what some of the current work is and some reflections on that. And hopefully we'll have time for questions and answers. So here is a visual of the problem that we faced in 2010. And although the dates here are 2011, this is the grade 12 National Senior Certificate results, the performance in mathematics. And as you can see from the curve, it's a very distorted curve. The majority of students are failing. I'm just trying to find my cursor. There it is. The majority of students are failing and a small minority are succeeding. These are higher grades. You can see this is getting 60%, 70, 80, 90. These are all failing grades over here. So the majority of students that are coming through to grade 12 are failing mathematics. A minority are being successful at mathematics. So what this is described at what we did, we said there's access for all. So all post-apartheid, all children are now in school, and that is a huge that's huge progress from 1994 when a lot of students were out of school. But there's only learning for some. So there's a problem, there's an issue of access. We've solved the access problem, but we haven't solved the quality problem. And so what we thought in the project is there any way that we can intervene to shift this curve? And we were talking here, this is at the grade 12 was where we had these results. And what we did in the first year of the project, which was in 2010, is that we went into schools and we did diagnostic assessments. We focused on algebra, basic algebra, because without a grasp.
Jill, sorry to disturb you.
Yeah.
Could you just say how many students we are talking about here, roughly?
What do you mean?
How many students are we? I mean, these curves that you showed. What is the
So
sample?
it's the national. It's the whole population.
Entire African, entire South African.
That's the entire South African population.
Okay.
Sorry, yeah. Please interrupt if there are things that are not clear. Okay. So in 2010, we went into the schools, but we went into 10 schools. Selected, these were all low fee, so in low socioeconomic areas, and we did some basic algebra diagnostic assessments. And we found, actually, we tested in grade 8 and grade 10, and what we called the foundations were very poor and unstable. That meant that we couldn't identify errors. The student results were all over the show and very poor. The next year, there was a national assessment called the Annual National Assessment, ANA, and the results at grade 9 reflected exactly what we'd found in the schools. This is the percentage pass of that test that was set nationally, 13%. It's extraordinarily low. So it was quite clear to us that the problem in the secondary school was lower down in the school. It was in the grade 8 and 9. It was not that by grade 12, the horse had bolted, we needed to try to intervene lower down in the school. And while these are national figures, I think what's also important is, and this was reflected in the TIMS study, that there's a huge socioeconomic gap. So even though a small number of students are passing here, the majority of students who are doing well are in the middle class areas, and the majority of students who are failing are in the low socioeconomic and poor areas. And I think this is a situation that India knows well.
Yes. I think so.
Okay, so, I don't know why that yellow thing came up. One of the things that we knew at the time, and I think it still remains, is that in context of poverty and inequality, what the resources are that the school has matters a great deal. There's not so much support in the home, and so what happens in school is really very important, and it's been captured in a lot of research that says attainment in contexts of poverty is much more sensitive to the availability of school resources. So I did some work on, what are resources in the school? And this is a representation that colleagues of mine did more recently to say we need to understand that resources in schools are human resources, the teachers in particular, material resources like the curriculum, textbooks, and so on, but also cultural resources. So you're a multilingual country like we are, and so students come with very different language proficiencies in different languages, even though they're multilingual. These things have an impact on learning. These are cultural resources, and these distinguish the different areas in terms of who's fluent in what. The thing that's important that's coming up there is, what does it mean if you want to try to do something that ultimately can scale up? So you don't want to intervene just in a small area, you want to intervene at scale. And what we found over time is that you can scale up the delivery of materials. You can certainly put out new textbooks, new curriculum materials, artifacts, teaching resources, Unifix cubes, different things like that. But it's extremely difficult to scale human resources. That takes time, because actually teacher development, teacher education, teacher learning, all of that is time intensive, labor intensive, and expensive. So you have to know that, in fact, if you're going to actually resource schools, all these things are important. And so when you do an intervention, how do you select? And I do that because I wanted you to have some background as to why we chose the intervention that we did. So I want to move on to just a little bit of background, because this helps you understand even more why we chose the intervention that we did, because I want to point out the resources in the schools. So I'm talking here about schools where the students either don't pay any fees at all, these are all public schools, or they pay very minimal fees. So we have a structured system. We have schools where they charge fees, and of course the middle classes go to those schools. So typically in these schools, you have students coming from, and they're serving communities where there's very low socioeconomic conditions. So these are the schools that I'm talking about here. There's a highly prescriptive and regulated curriculum. Teachers have an annual teaching plan they have to follow, and day by day teaching designs that they should stick to, and they're monitored. So we're working in a context here in these schools where teachers are highly regulated. There are limited, very limited resources in the schools, and both material and human. And what I mean by the human, low human, I'm going to come to there. There's very little technology. Schools now would have more access to electricity and water, but this has happened over time. And what we have, and COVID has made this absolutely much more significant and serious, is learners are not necessarily prepared for the grade they're in. What I mean by that is you might have students who have passed through the primary school, arriving grade 8, and their number work is even poor. And so this is when they need to start learning algebra, and this becomes very tricky. So teachers are managing their work in the secondary school with limited resources, very little access to technology, and learners not prepared for their grade. And under COVID, post-COVID, this is even worse. What we found in the lower secondary, and those are grade 8s and 9, is that we've had many teachers who we would call were teaching out of field. They were trained as primary teachers and primary maths, and so they didn't have secondary level training in mathematics or higher mathematics. Or some of them were actually not trained as mathematics teachers, but they tended to be teaching in the lower grades. So what was happening in the schools at that time was that the better qualified, mathematically qualified teachers were teaching in grades 10, 11, and 12 towards the exit exam, and not in the lower schools. So for us, it was very important that teachers' knowledge as a resource in the schools was a serious issue. Okay, if we're talking about resources in schools, teachers' mathematical knowledge was a serious issue. These are just pictures of what the schools look like. When we observed teaching, we found that, I'll just talk about it very briefly, the teaching was what we called incoherent. So I would sit in a lesson, and it was on algebra, and it would be on factors, for example. And I'd come away from the lesson and I'd think the students, they did quite a lot of work, but did they even understand what a factor is? Did they have any sense of what it is they were working with? Was there a coherent mathematical story that they could go away with and have more generality to what they were thinking? They did do little bits of knowledge, but I didn't think that they would be able to hang together to anything that was more generalizable. So it was clear to us that this was probably a function of the curriculum as well as teachers' knowledge of what they were teaching. So, sorry, I don't know why that came in. What did we do? I wanted to say briefly what we did, how and why. We decided that the most important thing we could do was pay attention first to teachers' mathematical knowledge for teaching. Okay, that they needed to know the mathematics that they were teaching well enough and deeply enough to be able to teach grade 8 and 9 well. And that if they could do that, if we could improve their knowledge base, we thought this would lead to learning gains. We of course knew that you had to attend to pedagogy, but in the forefront for us was that if there wasn't a stable base on which their mathematics was built, then no amount of good pedagogy would be actually helping them. These are intertwined. And so I'm saying this because we favored mathematics. It's not that we didn't do pedagogic work. So we focused on maths content knowledge and pedagogic content knowledge, not worrying about the boundaries between these. So we would focus, and I'll give you examples of what we're doing on why working with multiple representations, for example, is really important, and making sure that teachers could do this themselves. Sorry. Oh my goodness, what have I done? Sorry about that. I pressed escape rather than. Okay, we're back.
Yeah.
Okay, so so we wanted to pay attention to pedagogic content knowledge and how you teach, but what we wanted to make sure we did was that when we focused on mathematics, the teachers were thinking about their mathematics and working on their mathematics. And when we were focused on teaching, they were thinking about their teaching and focused on the teaching and not necessarily blurring these. Now, many professional developments and in-service teacher education do combine these. It was a very specific and explicit choice that we made to focus on. We linked them, but when we focused on mathematics with them, we wanted them to just have more time to work on mathematics without worrying about whether they can teach this. Our theory of change also said that we knew when we were working with teachers that we would have a direct effect on teachers' knowledge, but an indirect effect on their classroom practices. Okay, and I'll come to that when I report on some of the results. So this was the course. We called it Transition Maths. We focused it for grade 8 and 9 teachers because we wanted them to be able to teach at higher levels and to engage with higher levels of mathematics. So we wanted them to be able to transition to grade 10 and so not stay only with knowledge of grade 8 and 9 mathematics. We pushed them higher up in the curriculum. We never pushed many of them beyond grade 12 maths. We started this in the third year of the program because we found working with teachers in schools, they were too busy, they couldn't attend to their own learning. So we arranged with the provincial department, we worked with 10 schools, for them to be released from school for 16 days over 1 year. So the teachers came to campus for 2 days, 8 times a year. It was quite a controversial decision, and we got the province to agree because they had to leave their classes and their other teachers had to cover for them. So the school had to agree and make arrangements, and the teachers had to agree to invest so that ultimately it would benefit the school as a whole. We focused 75% of the program was focused on mathematics and 25% on teaching. And for that, we used a framework that I'll talk about so that we had a common and shared language to talk about teaching. We focused mainly on what we found were problems and what we thought were underpinning mathematical ideas in the secondary curriculum. If you don't actually get some grasp of symbolic forms and can work with algebra, it's very difficult to progress through the secondary curriculum. So we worked with algebra and functions. We did some work with geometry and trigonometry. More recently, we've done more work with geometry, and I'll tell you about that later. I'll explain what the teaching framework is. We worked on tasks with them on what it means to set a goal and how do you then establish a lesson plan for that. They did do assignments. They did have to sit assignments and tests through the program, and they got what we call professional development points for the CPD points for taking the course. We wanted to be able to see whether they improved so that we could also do the research, and we wanted them to commit themselves. So if you're interested, I can tell you about all the controversies about testing teachers that we went through, but I won't go through that now. So in phase 1, which was 2012 to 2014, we worked in 10 schools in 1 district in the province in which I live. Gauteng, where Johannesburg is, it's the most urban, most populated, most multilingual context. We had 45 teachers, and in phase 2, we expanded out. We expanded out to 6 districts, to 70 schools, and many more teachers came on the course. So in terms of scaling, it's a lean model because it doesn't cost that much to deliver. There's no coaching in the schools, there's no classroom-based support, though we did do lesson study with some of the teachers, and we did a version of it inside the course. So this is not a labor-intensive professional development program where there's support in the classrooms. So in that sense, we have been able to scale it, but only to a certain degree. It's a long-term program. Without a year of the teachers participating in doing mathematics, we don't think this will work. So what were our principles for doing mathematics, for doing teaching, and our PD approach? So for mathematics, we knew these are teachers, they'd learned mathematics before, but we weren't sure of the quality of what they knew, so we revisited school maths and we extended the maths that they knew. Our orientation, just from a theoretical point of view, is to view mathematics as a connected set of scientific concepts. It's a discipline, it's hierarchical, it's powerful in generality, but actually in itself, mathematics is quite opaque. So mathematics is very abstract in terms of how it's represented. It has to be represented in some way to students, but at the end of the day, they also need to appreciate the abstraction. We wanted to do this because we saw that actually the teaching was very incoherent and fragmented, and we thought that teachers would benefit from experiencing for themselves in a much more explicit way mathematics as a connected, meaningful, powerful way of thinking that enables you to generalize, that enables you to represent the world and solve problems in the world. So that was the experience of mathematics that we wanted to give them. And we thought that with that experience of mathematics, it would filter into their teaching. We know there's no direct relationship, but that it would filter, and particularly also because they're experienced teachers. For teaching, we know that teaching is mediated by resources. These are cultural, they always carry meanings, and not everybody appreciates resources in the same way. So you can put an artifact in front of the students, but they won't all see it in the same way. We also wanted them to be able to see that if they were teaching a lesson, the mathematical content of the mathematical story of the lesson needed to be coherent. There needed to be a mathematical message that they understood that they were trying to communicate with students. And this was because the teaching was incoherent and out of focus. And our PD was focused very much, I'm not sure many of you are au fait with this, but there's a huge literature on professional development and what makes it successful. And some of these criteria, or some of the characteristics of a successful PD program, is that it's content focused. So it needs to be maths focused and not focused on general pedagogy. It needs to happen over time. Teachers need to work together as a community of practice. And we added the fourth one. Our approach is that we wanted to strengthen what they did and not necessarily upend what we thought were rather fragile practices anyway. So we didn't go in with a massive pedagogical reform agenda. Our main goal was to strengthen the mathematical base of what they were doing and to see if teachers could establish more meaning in how they were dealing with mathematics, that in the longer term, we could deal with more task-based work, more open-ended learning, more problem-solving learning. We weren't going there in the first instance. And this is also because we were respectful of teachers' work. Teachers were working in, I told you, a very, very constrained environment. They were working with a highly prescriptive curriculum, and it was their job to teach it, to get their students to pass the tests and exams at the end of the year. They were working with minimal resources, so we were respectful of those conditions and therefore trying to work with what they had, extending it, disrupting it inevitably, but not trying to overturn it in a way that maybe would make it impossible for them to implement and fulfill their responsibilities as teachers. It's a debate in the field, and I'm happy to take that up later. So here's an example of what we would do with the teachers on revisiting mathematics. You can see here, this is a straight line function. It's a linear function. It's grade 8 and 9 work. It's very straightforward. But what's not straightforward about this is how it can be represented in very different ways. It can be represented as a function machine. It can be represented in a table of values. It can be represented as a graph. It can be represented as an equation. It can be represented in verbal expression. And all of these are the same story about the same object, this function. One of the things that the teachers didn't know is how these things connected. How do you see the intercepts in the table, in the equation, maybe in the function machine? What does the graph afford? What does the equation afford? What does being able to say it in words help you think about what this function means? And that ultimately a function is a relationship between two variables here, and the one changes in relation to the other. Those things were not part of what was deeply understood by the teachers. And so we worked with them with multiple representations of key ideas in the curriculum. And just as an aside, there's a lot of current work on language responsive teaching and translanguaging in classrooms. And most of that research is pointing out to how important multiple representations are, as well as working across languages and across registers in language. So this kind of work is very important when working with teachers and working with people who are going to be teachers to strengthen the underlying ideas that they have. And something like function is a concept that's not well understood. So these are the things we would ask. Where is the intercept in the table? Where do you see the intercept in the graph? Where do you see double in the graph? It's obviously linked to the gradient. These are the kinds of questions that deepen their insight. This is an example of doing something that they hadn't done before. These are rational functions. This is not part of the school curriculum. Some of the teachers might have seen rational functions before, but for most of the students, the teachers, this would have been very new mathematics. So these are the kinds of things that we would deal with them, and we would give them a very unfamiliar function, a function they hadn't worked with before, and so it was very new to them. And these particular examples, you can see there's something at work here. It's what we call principles of variation. We have the same expression, x minus 2, if you like, in each of them, but in various forms, related to the root and related to what's positive and what's negative. And these generate different functions, they generate different graphs. And what's significant about this choice is that it brings to life domain and range. So the task for the students here would be to first of all sketch them. They're not given the sketches to start. They would first need to sketch the graphs, then determine the domain and range, and then write out their reasoning. So you can see what we're working with here is modeling principles of variation, connecting representations with something for themselves, that they're learning something new, and communicating their thinking in words. Okay, and this is crucial in multilingual classrooms, where often there's, certainly in our classrooms, there's a tendency to reduce how much talk there is in the class, because there's a concern that if they're trying to teach in English, that students won't be able to speak. So there's more focus on activity rather than on talk. But in fact, if you don't talk these things through and communicate using mathematical words and partial mathematical words, link them to everyday ideas, then mathematical concepts don't have an opportunity to grow. Okay, so that's how we deal with mathematics. When we work with them with teaching, and you can see it's embedded in the tasks we gave for mathematics, we talk with them about establishing a lesson goal. You must be clear about what's the mathematics you're trying to teach here. There could also be other goals. I want the learners to learn how to be nice to each other or to communicate with each other. All of those goals are important too, but we wanted them to be absolutely clear what their mathematical goal was and how they were articulating it. And if that was the goal, what kind of tasks would you set? What sort of examples would you include? How would you vary the multiple representations around that so that these would reach the goal? What kinds of words do you use? How do you argue and reason about this kind of mathematics? And key to all of this is both what the teacher says, but also what the students are doing. What kind of mathematics are they doing, and what opportunities are they getting to talk? And at the end of the day, how will you know whether students are able to do what you intended? So that's a very simple framework that we used with teachers to think about planning their lessons, to look at textbooks, to look at other examples of lessons, and particularly the lessons that they were given that they had to teach, to say, is there a clear lesson goal? Are there enough examples? Are the tasks demanding enough? Are they working with multiple representations? It was a very simple framework for them to actually start to think reflectively about their teaching, and one that we could then develop a shared language to work with them. So when we dealt with this, one of the things that we thought was very important, because we were working with algebra and we were working with the text that they had, was to use principles of variation. So these are being used all over. It's very, very part of Chinese teaching, but it's been used in Scandinavia. It's used in a lot of places now, that and it's very crucial to mathematics. Mathematics is built on what's invariant, so that you can generalize and you can see underlying structure. So working with principles of variation is very helpful. And this is one of the difficulties that we know from working with the learners that they have, is that they misapplied simplifying when there were brackets. And the teachers wanted to work on this, and we did a lesson study with this. And so here is a task we developed to work with teachers, to talk with them on, so if you can see again, the same elements of the expressions are here, but the position of the brackets are very different, and we're changing the sign. Okay, and we can ask them to, compute the answers of all of these, and then figure out what stays the same, what's changing. How does the position of the bracket impact this? And what is it that's doing this? And then to pull out from that, it's the use of the distributive law, and how the distributive law functions in these different representations and these different forms. Pairing them and what you put together really helps you see the difference and see the difference in the results. And so we found this way of working with teachers on mathematics that they were going to teach very, very useful. We also worked with teachers on what it meant to produce a full explanation. Now, anybody who's taught maths in school will recognize this problem. It's called conjoining, or I think that's the main word for it. So teachers, many students would know that 5p and 4q are unlike terms, and that they can add like terms but not unlike terms, and yet when they get a variable and a constant to add, they will conjoin them and add them together. So I'm sure this is a very common thing. We see it all over. It's very common in learning algebra, no matter where you are in the world, even when you're not working in a multilingual context. So this is one of the tasks that we would give teachers, is how would they convince a learner who writes this that he or she is wrong, or there might be, and I wouldn't use the word wrong. It's interesting, we've changed that. That how would you convince them that their reasoning is faulty? Of course, that is valid if p is 1. It's not valid for any other values of p. And if they could think about doing this in multiple ways, because this would help their learners, and could they explain this in words to themselves, and therefore how would they explain it to learners? They did this in groups. They shared their ideas with each other, and then we could look at how did teachers construct explanations with these? How did we come to understand what they thought were good explanations? And how could we work with them to encourage fuller ones that were more mathematically robust? So we had principles of these when we worked with teachers on things like the teaching practice of explaining. And I know people don't like this when you talk about explaining, because it sounds like teacher talk. And we're not talking about the teacher actually explaining all the time. We're talking about, in communication with learners, an explanation needs to be built. You need students working with the teachers to be able to say, well, is 5p plus 4 equal to 9? And if not, why not? And then how would this work? I see a hand up, yes?
Professor Adler, just reminding you, you asked me to remind you at the half an hour mark.
Oh, okay, good. I must speed along because I need to get to the research results. Thank you very much. Okay, so I'm not going to go through the details on this, but we had principles of how did we design this as a task for teachers. And you can see what we wanted to do was get the teachers to show us how they would trying to explain this to themselves and how they might explain it to their students, so that we could discuss this with them. And I'm not going to talk to the slide in detail other than to say that this was the most common explanation that teachers gave. That if 5p, you can think about it as 5 pencils, and 4 is just a number, you can't add these together. Now there's an underlying concept of variable that's not at work here. And so while they're trying to link with everyday practices, and this might help get the right answer, it actually doesn't communicate with learners what the meaning of P is in 5P. And so we'd work with teachers for quite a lot of that. How can you do this by connecting to everyday problems and so on? So I'm going to spend the last 15 minutes now saying, so we did that. We worked with teachers in the first 5 years, just with a smaller group, in the last 3 years with over 100 teachers. And we did research, and I'm going to focus on the research in the later part. And we did qualitative and quantitative research. In the qualitative research, we were interested in seeing what teacher learning was. Did the quality of their teaching improve? And did they use the framework for themselves that we used with them? For the quantitative work, we knew the teachers improved. We could see that in their testing that we did, but we wanted to see whether it had any impact on their student learning. And so we did what's called a learning gain study, and I'll tell you quickly about those. So this is the team. None of this would be done if you're working on your own. And I had a very wonderful team who did a lot of the work and a lot of the research. And this is Dr. Punara, now Professor Punara, who did a lot of the PD work, and Dr. Leshota, who also did some of the PD work. There are postdocs here and students who are full-time doctoral fellows and postdoctoral fellows. And the postdoctoral fellows came from outside of South Africa. And so we had a very, very, very rich team working on all the research. Early research, just briefly, we were very interested in how teachers used resources. So did they use their textbooks? So Dr. Leshota did a study and found actually teachers didn't use, even though they were required to, teachers didn't use their textbooks deliberately. And this had consequences. So even where the textbooks were good, they were not being used as well as they could be. Dr. Pillay did a lesson study. We were interested to see whether this form of professional development that comes from Japan and is being used worldwide, but is labor intensive, dependent on resources in the schools, what would it look like to do something like this in very poor schools? And Dr. Pillay did the study. And he really did a fantastic job of working with 4 teachers in 4 different classrooms. They repeated lessons, they did planning together, and we were able to trace what teachers learned through that process. We were able to also see, was our hypothesis that there was a relationship between the quality of teachers' mathematical knowledge and the quality of their teaching in terms of how we set up the framework. And so we had data, we had video data from the schools, and we had 9 teachers who we had algebra lessons for in 1 year and then a following year. We were able to track them, but we were also able to look at the quality of algebra teaching. We had teachers who we had algebra assessments for, so we could see what the quality of their algebra knowledge was. And we were able to analyze their algebra lessons. And we did find a strong relationship between teachers whose mathematics was stronger, the way they were able to set up examples and use multiple representations, and the way they were able to build and explain mathematical ideas in their classes. So this was useful for us sort of for confirming our hypothesis. We weren't able to do pre and post video analysis in any more substantive way. We also did a lesson study I did it with a postdoc called Jehad Alshwaik, where we tested the framework. And we worked with just a small group of teachers each in a few schools to see if they could use this framework of how is mathematics, what's the goal, how's it exemplified, how do you think about its explanation, and what are learners doing and saying. And we found very good results with those. I'm not going to go through that in very much detail, but the lessons changed over time. And as the teachers taught lessons, planned lessons, taught lessons, reflected on their planning, retaught the lessons. They learned a lot about how to teach. They learned a lot about the framework, and they also learned more mathematics, which was interesting for us. There was a study on teacher identity, which I think is a big area of research, that teachers, it's not just enough for teachers to know what they teach, they also need to feel confident in themselves. And so who they think they are as a teacher and as a mathematical person is important. And so Foster and Tao from Ghana did the study on teacher identity, and we were looked at how they worked with the project. Did their identity shift in relation to what we were doing? And we have in this paper 2 case studies. I can give a list of the publications if you're interested in reading some of these papers. And what was interesting in this study is that there were 5 teachers, and they all learned. They all did identity development, but not in the same way. And that was very interesting for us to understand that teachers are just like learners. They come with different resources, they come with different motivations, and so they don't all focus on and attend to everything in these programs in the same way, and as a consequence of that, they learn different things. Also, the context in which they were working enabled them to practice some of the stuff in the classrooms, not others. So there were a whole lot of differences in how these teachers learned that was very interesting, all being in the same course. So I want to end with this study is the learning gains study, because one of the most difficult things in doing anything with teachers is how do you trace their learning to their students' learning? So my colleague Craig Punara ran the study with a lot of people. We did a pilot in 2013. So we took teachers in 5 of our schools where we had a kind of a comparison group. So 5 of the schools that we were working with at that time, not all the teachers came on the program. So we were able in 1 year, in 2013, to test at the beginning of the year students of teachers who'd been on the course, and then at the end of the year, those same students with the same teachers, and compare them with students of teachers who had not been on the course. And we had very promising results that the course made a difference. So the students of the teachers who had been on the course started off with lower performance and ended with higher performance over the same amount of time. Okay, that suggested to us that the course the teachers were doing was having an impact on their teaching, on the quality of their teaching, and therefore on their students' learning. But of course, there were real limitations to the study. The sample was small, the scores were low, but also it was a kind of a biased sample, because the teachers who'd come on the course were those who selected to come on the program. They were probably more committed teachers. So we knew there were inbuilt constraints on the study, but it was nevertheless a way of testing how to do a learning gains study. And in the following 3 years, from 2016 to 2018, we undertook a much larger study. We had, you can see the number of teachers that were participating from the 3 years. These are 40, 39, and 46 teachers who had been on the course with us over those 3 years. We were able to look at their initial tests and their final tests. We saw great changes. And so we were able to see that for the whole cohort, all of those teachers that had been on the course impacted the knowledge we were offering them and the knowledge we then tested them on. The question remained, of course, is now what does this mean for their learners? And the important thing is the selection test and the final test were not the same test. This is not like a pre and post test for the teachers, because if we'd have given them the final test when they arrived to do the course, they would never have come back. It just would have been too difficult. So we gave them a much simpler selection test, but we had anchor items going into the final test. So the final test was much more difficult, covered much more content. And so the gains we see here actually underrepresent the learning gains of the teachers. Okay, so we did a similar learning gains study in 2018. We had, these are the teachers, the teachers who were on the course in 2016. here are the teachers who were on the course in there's 2017, where's 2017 as the squares? The teachers who were on the course in 2017, and this is very important, and we had a comparison group. So in this study, we had many, many more teachers, and we had a comparison group of schools that had absolutely nothing to do with the project. We were able to get the National Department to help us match the schools. Okay, so we matched the schools, and we were able then to test grade 9 and 10 learners of all of these teachers in the school, and the children were given a pre-test and they were given a post-test. Now, what you can see from the graph before I put up the information is that these are the two cohorts who came on the course. You can see that the 2016 cohort, their students progressed the most. The 2017 cohort progressed almost similar to the control group or the comparison group. And what's interesting about this is that it shows that actually the impact of teacher learning is deferred. It doesn't happen immediately. So this was done in 2018, and the teachers who were on the course in 2016 were teaching better than the teachers who were on the course in 2017. So just to look at these results in more detail, we were able to track we looked at only the teachers who were in the sample here, and the 2016 teachers had a greater impact on their learning than the 2017 teachers and the comparison group teachers. The gains of the 2016 TM1 group are significantly different. So we were confident from this study that the teachers over time were making a difference to the quality of the learning of their learners. Here is just the learner results. So we don't have time, and I'd rather stop there to go into the detail of the results. I've tried to give you just the overview. What are the practical implications of these? I said there is a delayed impact, but the differences were significant enough to account for a good few months of teaching. So the students of the teachers in the 2016 cohort, they were performing at a level that said they had the equivalent of 8 months or 6 months additional progress. And this is significant. So that's the conclusion. We ran the project. It was very hard to do it. It was time demanding. It was a big team that ran it. We had amazing funding to do this from the National Research Foundation and from one of the banks. The university supported us doing this. And the ultimate results in the end were what we'd hoped for, and our hypothesis that if we worked on teachers' knowledge, which we thought was the starting point, it would lever up learning gains for their students. There's much more to do. The learning gains were there, they were significant. They were not good enough in the sense of students weren't necessarily performing at high levels yet. So that was the result of the intervention. And I thought to talk about that because it gives you a perspective on a very large project that a group of people do in a maths education environment, a kind of a research institute like you have, where you can do long-term research and have students, PhD and postdoctoral students, who are working at different levels and on different pieces of the research. So in the last few minutes, and I've probably gone over time, but in the last few minutes, I'll say, so that was all before COVID. What would we do now if it was post-COVID? Well, one of the big differences, we already found in the schools that learners were not at the level of the grade they were in. It's much worse now. So if we were going to do an intervention now, we would have to work with teachers on how to bridge some of the gaps that have just widened. So it's not that students haven't moved from grade 4 to 5 or 6 to 7 or 7 to 8 or whatever, but they're coming in with, people talk about learning loss. Some say that's a deficit discourse. I think there has been learning loss. In other words, they knew more about number and algebra than they did a year and a half ago. or 2 years ago. And so there's an enormous amount of work that needs to be done. And so we have worked in the last 2 years to develop materials for teachers to use to do catch up, to work on key concepts in the curriculum and how to do these alongside a curriculum that's in work. I've been working on geometry, and the geometry framework is very different. Geometry is very different. Representations are very important in geometry. Working with geometry, proof is very different. So it does depend on what topic you're working with, what content you're working with, and therefore I would say when you're working in science, in physics or chemistry, doing these kinds of things would also be different. I want to just end with one comment. I made it a little bit earlier, is that in our teacher education, in all our schools, English is the dominant language. It's not the majority language. It's the post-colonial language. It's still very powerful. It's the language of government. It's the language of commerce. It's the desired language. It's not the language most people speak. It's the language in all teacher education. So all teacher education curriculum is in English, and all school curricula are in English from at least grade 4. So we worked with teachers in English. When we worked with them and alongside them, they of course used their languages as they talked to each other and talked to those of us that could talk with them in different languages. But we didn't focus on language, and if I was doing it again, I would do so, because I think we missed opportunity to work with them much more carefully on how their languages, how different languages function. And different languages have different registers for carrying mathematical ideas, and these are very important for teaching. So I know that from my earlier research, we didn't focus on it, and I would do it now, and I would work much more on what's called translanguaging, which is being argued as very important in post-colonial education, to work with the resources students bring, all of them, to work with multiple representations, to work with their everyday knowledge, and to build from those to what it is you're trying to teach. And of course, STEM is where it's at a kind of organizational level. I don't really know what's happening in STEM education more broadly, so I look forward to your questions related to that. Thank you very much.
Thank you very much, Professor Adler. That was a wonderful talk. I'll wait, maybe if the others want to ask a question. I have a couple I want to ask, but I'd be happy if somebody else wants to ask a question. We also have some people watching on YouTube, so if there are any questions from there, I will relay those. I'm going to allow all participants to unmute themselves, so you can just unmute yourself and ask your question.
Okay, should I just stop sharing?
Yeah, that'd be
yes,
fine.
Please. Yeah.
Okay, where is that now?
Bottom center.
No, it'll be at the top,
end the
top
show?
of the screen.
Or top center.
I need to end the show first so
Yeah.
that I can do that. There we go. There we go.
Okay.
Yeah.
Right.
Okay. At least I can see one or two faces, which is rather nice.
Pooja, may I?
Yes, absolutely. Please go ahead. I'll take a look at the YouTube questions.
Sure. So Jill, thanks a lot for a very, very nice talk, a very nice overview of your work and your research. I must say that this reminds me so much, or it almost seems like a page from an Indian story. Very, very closely matches what we I think have in our country. Even to a great level of detail, it seemed very similar. The multiculturality, multiple languages, English being the desired language, the dominant language of exchange, if not of practice. And also the weaknesses in mathematics preparedness of students. All this resonates very much with our conditions here. Is my gut feeling. What I found interesting is that you could have this sustained program for such a long time and see positive benefits out of your intervention. My question is, when these teachers who get trained with you in this new format, go back to their classrooms. How much of what you do gets transacted directly in the classrooms, and how much do the teachers improvise or come up with newer ideas on their own, adapting to their local conditions?
Yeah. So, I mean, it's an important question, very important question. The answer to the second part is teachers will always improvise and change to suit their conditions. Teachers have agency, and it's important. Nothing that you do will ever be, taken up with fidelity. You can't assume that because this is what it's going to be, it will change. There's no question about it. It's how that changes and what's important is what's important. Now, our studies didn't go beyond the end of the project. So we certainly know that some of the teachers that participated with us continued the work and influenced others. The best indicator for us that it was of value to them and to their practice, and so to the school, was that if teachers came one year, the school would send teachers the next year. Okay, that for us was the best advert. We didn't have to go and then beg,
Right.
Actually, we would say to the schools, if teachers want to come, they have to apply. And we have to accept them because the school has to agree to them to come. It has to be beneficial for the school. So we know that at the level of the teacher and the difference that it made to how they thought about themselves and their mathematics, and therefore energized their teaching again, was good. The conditions in which they're working and what COVID did could have undone everything. Do you know, if I went into the schools now, I think this framework that we presented them would be in some of the teachers' heads. They would think about it, but they're under such pressure at the moment. I wouldn't expect to see some of the detail that we would have expected 2 years ago. They're just under the whip. And so the answer to the second question is that I don't know, and it's too difficult a time. There was too much disruption to be able to say, what was the continuity of this? And honestly, I would say that not being a teacher in the school and not having to manage what they've had to manage, I don't know that I understand well enough what it is they had to learn in the last year and a half on the hoof. They didn't have technology. They worked with WhatsApp with students who had phones, if they had phones. So much has changed. It was interesting for us. Last year, we offered a course in geometry, and many of our teachers came and did that course, and others came and did during COVID online, because I think they also need stimulation and interesting things. But I know the work conditions they're just hard. So I'm afraid I can't answer that well enough. The research tells you that sustaining the stuff is very difficult if there isn't continuing support or a continuing professional community that supports it. If teachers are on their own and the school is coming down on them with too much work, too heavy a curriculum, it's extremely hard to sustain these things.
So how easy was it to get school administrations to agree to letting their teachers go to this training, or what do you call it?
So we had provincial support. We had the support of the provincial department, and I think that helped. It was also a problem because we weren't the province. Okay, we weren't there. So we weren't their employers. But sometimes the province wanted to know how they were doing. Show us their results, and we said, no, it's none of your business. It's not you're the employer. We can't do anything about that. So it created some tensions, and then for some teachers, because the province was they thought it was also mandated by the province. So we were very careful to go to the school first and to get the buy-in from the principal and the head of the maths department. Okay, when we started in the first phase, we knew we could only afford to work with 10 schools. So we went to about 15 schools, offered the program, and asked them to come back to us to say if they were interested, that we could only choose 10. And I think we sort of created a little bit of, we're not coming to force you to do this. we're coming to say, you must select in to do this. And so those that did selected in, and of the 10 schools that started, I'd say at the end of 5 years, we still had a very strong relationship with 6, not all 10. Principal had changed, head of department had changed, teachers had moved, all those things. And of course, there was funding.
Yeah,
okay, there was funding. So neither the school nor the teachers were out of pocket. So if the teachers came, we could pay their transport. The schools were given resources for releasing the teachers. We couldn't give money. But we said at the end, if the teachers complete, they would, we gave them data projector, 2 computers, some textbooks. So there were some benefits for them, some material benefits for them, not equal to what it cost, but we thought we couldn't do it if it was any cost to the school or the teacher. Okay, so we covered the costs.
Bhas, may I?
Yeah.
I have a small question, Professor Adler. This was wonderful, and I think it's. I have a student who works on English language proficiency among school children in Urdu medium schools. So for me, the question of language is very interesting. So we had a workshop where a few teachers showed us samples of translation from English into vernacular medium, a textbook translation, so translations of textbooks from English into vernacular medium, into vernaculars. And there were a lot of problems with the quality of translation, with terminology and so on. So did you feel during this project if the textbooks were also something that needed to be overhauled, or were the textbooks, in your opinion, not the problem?
So here's the difference. In the textbooks that we working with at a secondary level are only in English.
Okay.
So there's no translation. And there were a range of textbooks, and some textbooks were awful and some textbooks were very good. Okay, so we were able, through, not by saying this textbook's awful, but by saying we're going to look at these 3 textbooks and look at how they do this lesson. Now, which one would you choose? What would you take from which? And it becomes pretty obvious which textbooks are doing a better job. So we certainly worked with them with the materials that they worked with, but they only worked with English materials. That said, I'm busy working with a man from France, and there's been a lot of work on translation. Translation's an enormous issue. Okay, and I'm doing a study. My postdoc is from Malawi, and we looked at so not her, but a project that she's involved in, and somebody else wrote the paper. They were working in the 1st grade and teaching the concept zero. And Chichewa's the national language. It's not the official language. English is the official language. Chichewa's the national language. Most people would speak Chichewa. There's no word for zero in Chichewa. The word for zero in Chichewa means nothing or empty. Okay, and it's not a concept of a number. So if you're trying to teach zero as number, you don't have the language in Chichewa with which to do it. And if you only use the Chichewa words, and you don't know that you have to complement those and explain why those are not the mathematical word. And so we need a new word for that. And we can use zero, we can use the English word, but that's the word when we mean the number. Not that it's empty, when we're talking about the number. And the move from zero as nothing to zero as number is one of the key changes that students have to make if they're going to move from natural numbers to integers. Okay, so the languages matter profusely. And if the text, so what we were working with there, which was very interesting, we had the teacher's guide was in English, the student textbook was in Chichewa, and the teacher education was in English. Okay, and we look at all the data, and nobody dealt with the issue of zero. The teachers were teaching zero. Nobody knew that it was a problem. So, how, you've got to do some of the study to see this. And this is where the translation wouldn't even help, because the translation in the Chichewa textbook was the Chichewa word.
Right.
Okay. So it matters profusely. And I think that when this is happening, and we're learning about this more and more, is also translation is cultural. So the word, it's not just word for word.
Mm.
It's the meanings that they're embedded in and how you use the expressions and how you would use the expressions in the maths register and how you would translate that. Translation into words is just like a first, like minor step. And unfortunately, some of the textbooks are just translated by people who don't understand the mathematics and they don't understand what translation means, leaving teachers in a predicament.
Mm.
Because if they, so we've been working now with the geometry teachers on the textbook, working more at what's expressed in the textbook in the Malawian situation and what's not in the textbook, because also then the representations that they give to try and teach these concepts will be flawed. Okay, if you don't understand that there are problems, if you want to present 0 as something that's a number, you have to bring the number line in. Okay, you can't just be working with empty trays and pebbles, and you can do some of that work, and you could go then up the curriculum with just about so many different concepts, and then what the words are you would use in the vernacular, and whether these words then help carry the meaning or they don't. So there's another study that's just been done here, a PhD that was finished in Sepedi. And interestingly, the number words in Sepedi reflect the place value. So the number for 11 is 110.1. The number for 12 is 110.2. So actually using Sepedi would help.
Mm.
Okay, so and teachers learning about this and what the languages carry, and then all the power around what languages are powerful, what are not, is fraught. It's fraught. And I know in India, in all your regions, you're working at least in 3 languages. The local language, Hindi, and English. Yeah, so it's complicated, but I think what the thing I would say now is, and what I would be doing now, is just making teachers more alert to this. Okay, they need to think about what's the word in English, what's the word they're using, do they mean the same thing? What could they do to actually help learners use those words, but then use them towards what they're trying to learn?
Yeah, no, I think that's a very critical point, especially in societies like ours, which are hugely multilingual. Great.
And I think that's just to, if we've got a minute, some of the research on translanguaging focuses on how the different languages are used and whether the different languages are used and how fluid it is. All that is fine, but if you're not focusing on the content and what it is they're communicating about, you lose half the story.
Yeah, I think I think the content bit has to be focused and probably has to be primary to this kind of.
Well, it's what we talk about. You have to have the linguistic skills and the epistemic skills.
Yeah,
absolutely. You can't deal with the one without the other. And I'd say in the project we focus more on the epistemic than the linguistic, and if I was doing it again, I'd do more on the linguistic.
Yeah, it's great. We have a question on YouTube. Would you mind? I'll just read it out for you.
Sure.
Okay, so the question is about, is there any opportunity for Indian teachers to come to South Africa to participate in a project like this? Is such training happening for mathematics teachers in India? I think for the latter part, we were going to try and put something together, and there are programs in India as well that do focus on mathematics.
So that said, we've got materials online. And if you want access to some of the stuff, just let me know and I can send you web links. I can send you links with papers. So we've written papers on how we did some of the PD, how we taught them about examples, how we taught them about explanations. And there's a lot of materials online now of what we've been doing with teachers in schools now to catch up some basic mathematics. And they're open source, so you would be able to access all the materials. So just let me know, and then I'll get Craig to send you the links.
That sounds wonderful. Thank you so much.
Sure.
Yeah, I think it's a little bit late in the evening. If there are no more questions, then I'd like to thank Professor Adler for this very wonderful talk. And we hope that the next time you're in India, you will come by and visit us in
Sure.
Pune.
Yeah.
I'll definitely make contact. So thank you for the invitation again. And I look forward to meeting you somewhere.
Sure. Thanks a lot. Thanks a lot. Yeah.
Bye.
Bye. Have a nice day.
You too. Oh, evening.
Well.